Hi, welcome to my new video of Python series. Today we are going to learn about generators in Python. Before starting the video, if you are new here, please subscribe the channel and hit the bell icon to receive every new video updates. Also do check out other videos on our channel, I will attach link in description. What are generators? In computer science, a generator is a special routine that can be used to control the iteration behavior of a loop. A generator is very similar to a function that returns an array, in that a generator has parameters, can be called, and generates a sequence of values. However, instead of building an array containing all the values and returning them all at once, a generator yields the values one at a time, which requires less memory and allows the caller to get started processing the first few values immediately. In short, a generator looks like a function but behaves like an iterator. Python provides tools that produce results only when needed. Generator functions. They are coded as normal def but use yield to return results one at a time, suspending and resuming. Generator expressions. These are similar to the list comprehensions, but they return an object that produces results on demand instead of building a result list. We can write functions that send back a value and later be resumed by picking up where they left off. Such functions are called generator functions because they generate a sequence of values over time. Generator functions are not much different from normal functions and they use DFS. When created, however, they are automatically made to implement the iteration protocol so that they can appear in iteration contexts. Normal functions return a value and then exit, but generator functions automatically suspend and resume their execution. Because of that, they are often a useful alternative to both computing an entire series of values up front and manually saving and restoring state in classes. Because the state that generator functions retain when they are suspended includes their local scope, their local variables retain information and make it available when the functions are resumed. The primary difference between generator and normal functions is that a generator yields a value, rather than returns a value. The yield suspends the function and sends a value back to the caller while retains enough state to enable the function immediately after the last yield run. This allows the generator function to produce a series of values over time rather than computing them all at once and sending them back in a list. Generators are closely bound up with the iteration protocol. Iterable objects define a next method which either returns the next item in the iterator or raises the special stop iteration exception to end the iteration. An object's iterator is fetched with the iter built-in function. Let's have a look on example for functions. Here are the things happening in the code. The presence of the yield keyword in createCounter means that this is not a normal function. It is a special kind of function which generates values one at a time. We can think of it as a resumable function. Calling it will return a generator that can be used to generate successive values of n. To create an instance of the createCounter generator, just call it like any other function. Note that this does not actually execute the function code. We can tell this because the first line of the createCounter function calls print, but nothing was printed from the function createCounter. The createCounter function returns a generator object. The next function takes a generator object and returns its next value. The first time we call next with the counter generator, it executes the code in createCounter up to the first yield statement, then returns the value that was yielded. In this case, that will be 2, because we originally created the generator by calling createCounter. Repeatedly calling next with the same generator object resumes exactly where it left off and continues until it hits the next yield statement. All variables, local state, etc., are saved on yield and restored on next. The next line of code waiting to be executed calls print, which prints increment n. After that, the statement n plus equals 1. Then it loops through the while loop again, and the first thing it hits is the statement yield n, which saves the state of everything and returns the current value of n. The second time we call next, we do all the same things again, but this time n is now 4. Since create counter sets up an infinite loop, we could theoretically do this forever, and it would just keep incrementing n and spitting out values. Now, we are going to compare the functions with expressions. The same iteration can be coded with either a generator function or a generator expression. Let's look at the following example, which repeats each character in a string 5 times. The equivalent generator function requires a little bit more code, but as a multi-statement function, it will be able to code more logic and use more state information if needed. Both expressions and functions support automatic and manual iteration. Note that we make new generators here to iterator again. Generators are one-shot iterators. Both generator functions and generator expressions are their own iterators. So, they support just one active iteration. We can't have multiple iterators. So, for now we have learned what is generator functions and generator expressions. A quick question for your exercise. Look at this snippet. What will this next function print? Do this exercise and answer the question in comment section. Do you guys have any question in your mind? Do not hesitate to ask your queries in comments section. I will try to answer each of your queries. Also do check out my other different videos. Stay tuned for upcoming videos. Until the next time, goodbye.